Hello, good people. This is the Geometry Section 9 Review Key I'll be going through with you today. Alright, my classes. ABCD is a rhombus. What I know about a rhombus is that all sides are congruent. The diagonals bisect each other. And the fact that a rhombus is a parallelogram, we should know that. Opposite angles are congruent. So this angle here would be congruent with this angle, and these big angles here would be congruent as well. So if I start off here, DCA, note the angle we're talking about is that middle letter. So if I follow DCA, we're talking about the angle here. That is 3x plus 9. And they say the measure of DCB. Alright, so if I follow DCB, we're talking about this piece right here, this whole part is 12x minus 6. Alright, so if I wanted to figure out what x is first and then ABC, we've got to solve for x, we've got to set something equal to something else. So note, in a rhombus, this diagonal cuts this angle in half. So this angle is 3x plus 9. Over here is also 3x plus 9. Alright, so they're both 3x plus 9. I could add these together and set them then equal to 12x minus 6. That's what we're going to do. So 3x plus 9 plus 3x plus 9 equal 12x minus 6. And then we solve. Alright, combine some like terms, 6x and 18. Now I'm going to get all my letters on one side, my numbers on the other side. So I like to start with my letters, subtract 6x to the other side of the equal sign. Get my numbers to this side, so I'm going to add 6 to this side. Divide by 6, and x is equal to 4. So there's that first point on this review. Boom. And then I want measure of ABC, so ABC, if I find that, again, that's the middle letter of those three letters. B, alright, so ABC, we're talking about the angle here. I want that angle. Use triangles to your advantage here. I know this angle right in here is represented by 3x plus 9, and you just found x. So 3 times x, which is 4, plus 9, that's 12, plus 9 is 21. So this angle right here is 21 degrees. Well, in a rhombus, opposite angles are congruent, and this one's 21 over here is also 21 in a rhombus. Well, great. Now we have a triangle. I know there's 180 degrees in a triangle, so if I want to finish off this problem, I'm going to take 180 degrees and I'm subtract 21 plus 21, which is 42. So if I subtract 180 minus 42 there, 10 minus 2 is 8, 7 minus 4 is 3, drop down by 1, 138 degrees is the angle measure of ABC. Alright, rolling on to number 2. Decide if you are given enough information to prove the quadrilateral is a parallelogram for each description. Okay, so quadrilaterals. What all types of quadrilaterals are there that are parallelograms, that is? Well, easiest one I think is a square. Alright, you got all right angles. There's a square. You got a rectangle, that's a parallelogram. Alright, all my sides are opposite sides are congruent. It's my rectangle. You got a rhombus. Okay, so basically a square but slanted, kind of like a diamond. It's my rhombus. Just got a regular parallelogram. Alright, that's parallelogram. Okay, and then what other types of quadrilaterals are there that are not parallelograms? Okay, so other types would be like, say, a trapezoid. Okay, trapezoid. Or a kite. Alright, so. Alright. So then I'm going to go through and see if I can determine if this is enough information. So the diagonals are perpendicular. Is that enough to state that that's a parallelogram? Well, I know in a square, if I draw the diagonals in a square, those will be 90 degrees. Alright, so that definitely is a parallelogram. If I did diagonals in a rectangle, those are not perpendicular here, so that doesn't count. Rhombus, yes, they would be 90 degrees. Parallelogram, No, they're not 90 degrees here. Trapezoid, diagonals, no. Kite. If I draw the diagonals in a kite, yes, those are going to be 90 degrees. So these are not parallelograms, right? So all these are parallelograms, not parallelograms. So if diagonals are perpendicular, my counterexample is a kite. That is not enough information to prove that this would be enough for a parallelogram. Next one angle is a right angle. Okay, so if I have just one angle that's a right angle, is that enough information? I'm going to say no, because you could actually have a kite that has a 90-degree angle here, and then I could draw it like such. So there's one 90-degree angle, the rest are all different. That's not a parallelogram. One pair of consecutive angles are congruent. Well, I know in a square, consecutive angles, two angles right next to each other, those are congruent, 90 and 90, rectangle, 90 and 90. Rhombus, the consecutive angles, so the angle like here and here will not be congruent. So that's not what I'm looking for. A parallelogram, this angle will not be the same as this one, not what I'm looking for. Okay, so we have two parallelograms that do have consecutive angles are congruent, but the question is, can I find a counterexample? The answer is yes. A trapezoid, specifically if you had an isosceles trapezoid, right, here's your legs, where you have two legs, you have 2 feet. So here's a foot angle and here's a foot angle. These two are consecutive angles and they are congruent. Just like up here, these would also be congruent. So no, not enough information to prove we can have a parallelogram with that. Keep rolling. One pair of opposite sides are congruent. Okay, so one pair of opposite sides, well, again, I would use the isosceles trapezoid because these sides are congruent and they're opposite. However, that's not a parallelogram, so not enough information. Two pairs of opposite angles are congruent. That is literally the definition, part of a definition of a parallelogram. Two opposite angles are congruent. Every single parallelogram, opposite angles are congruent. Trapezoid, your opposite angles won't be congruent. Kite, opposite angles will not be congruent. But anyway, that is enough information, yes. All angles are congruent. Okay, so the only time we have all angles are congruent would be a square or rectangle, and those are parallelograms. There's not another way, another quadrilateral that would have all angles congruent and be a parallelogram, so that is yes, that's enough. Alright, down here, diagonals are perpendicular and congruent. Okay, so the only shape the diagonals are perpendicular are, if you remember, the square and the rhombus, but also the kite. But then they also said diagonals are perpendicular and congruent, but the diagonals are not congruent on the kite. They're not congruent necessarily on the rhombus, but they are congruent on the square. So that is a parallelogram. It's the only one we're left with. So yes, that's enough to prove that we have a parallelogram. One pair of opposite sides are both parallel and congruent. Parallel and congruent. Okay, so if I have one pair of opposite sides that are both parallel and congruent, so they're parallel and they're congruent, the only way then we would have to connect those, whatever's left there, it could have been like this, it could have been like this, they're parallel and they're congruent. No matter what, we are left with a parallelogram, so that's yes, that's enough. All four sides are congruent. Okay, so the only two shapes where all four sides are congruent would be a square or a rhombus, and both of those are parallelograms, so that's yes. Number 3. Alright, so far they say this big old shape here is a parallelogram, so we know opposite angles are congruent, and that's what we're dealing with. Those are all angles. We know there's 360 degrees total in a quadrilateral or a parallelogram. So what else do I know? So again, opposite angles are congruent. So they give you 120, this angle here. That is congruent to this whole angle here. So this whole thing is 120, just like up here. Now they want x. We can use our knowledge about triangles to our advantage here. So I'll look at this triangle right here. I'm going to look at this because this got me a 90-degree angle here. Gives you a 15-degree here. You can easily figure out this angle because we can take 180. Now we can subtract 90 and 15 and get what was left, right? So If I did that, I would get 75, and 75 goes here. Cool. Well, that's not what they want. They want x. Remember, this whole thing was 120. So to get x, we'd simply take 120, subtract 75, and 120 minus 75 is good old 45. So x in this case is 45 degrees. All right, number 4. One side of a parallelogram is 3 times, they should add times there, 3 times as long as another side. So the other side is x. The perimeter of the parallelogram is 24 inches. Find the lengths of the sides. So I'm going to draw a parallelogram. Could be a rectangle, could just be a regular parallelogram. Again, they said one side is 3 times as long as the other side. So it looked like something like this. They said the perimeter is 24 inches, so we're talking perimeter, we're going all the way around. So this side's 3x, down here is also 3x. This side's x, this side's x. So for perimeter, you're going to add up all these and set them equal to 24. All right, well, 3x plus 3x is 6x. X plus x is 2x. Set equal to my perimeter is just 24. Now that's 8x is equal to 24 divided by 8. X is equal to 3. So I go back into my problem here. This side then would just be 3. Up here would be 3 times 3, which is 9. Okay, so they say the length of the shorter side is 3. The longer side is 9. But number 5, a trapezoid and a rhombus are both what type of shape? Well, I know a rhombus is a parallelogram. Trapezoid is a quadrilateral. A rhombus is also quadrilateral. So which of these are the best? Well, they're definitely both not squares. They're both not kites. So what would be the best name possible? Would just simply be a quadrilateral, because a trapezoid definitely is not a parallelogram. All right, number 6. Ooh, yeah. Okay, so number 6 is a system of equations. You got to know this. If this is a parallelogram, the diagonals bisect each other. It means they cut each other in half. So this piece is congruent to here, and this piece is congruent to here. So I'm going to set up some equations. I'm going to use some white space here. So I know one equation will be 17 minus y is equal to 2x plus 5. The other equation will be these right here. So the other one is y plus 4 is equal to 2x plus 4. All right, because we have 2 variables in both equations, what y'all need to do is solve the system of equations. To do that, I'm going to use substitution today. Okay. So what I'm going to do is I'm going to solve one equation for one variable and plug it into the other. Not bad at all, promise. Right? So it's easy. I'm going to locate one variable kind of all on its own, and y is the winner. So I'm going to isolate it. I'm going to subtract the 4 over this way. So y is simply equal to 2x, because those just cancel. Then all I'm going to do is I'm going to replace back up here. I'm going to replace the y with 2x and solve the equation. I'm kind of running out of room here, so I apologize. So this equation I'm just going to rewrite. I'm going to replace the y with 2x. So it's 17 minus, not y, but 2x equal to 2x plus 5. And I'm going to solve for x. So I'm going to add 2x to this side, put all my letters on one side. So now I have 17 is equal to 4x plus 5. Subtract my 5 over. And I have 4x is equal to 12. Divide by 4 both sides. And x is equal to 3. If I want y, I'm just going to plug it back into my other equation here. It could be this one right here or below. So if I plug 3 in here, y would simply be 2 times 3, which is 6. Okay, so we got x is 3 and y is 6. Right over here, 3 and 6. And as far as what goes on here, that would be a parallelogram, and I can double check. If I plug those in, then I should see some same numbers here. So right here, y plus 4, y is 6, so 6 plus 4, this part's 10. If I do the same thing with this part, 2x plus 4, 2 times x is 6 plus 4 is 10 also. So we know this part's bisected. The question is, do we get the same thing here, or different numbers but equal? 17 minus y, that's 17 minus 6 is 11. And over here, 2 times x, okay, so 2 times 3 is 6 plus 5 is another 11. So we know this is 11, This is 11, this is 10, this is 10. Definitely a parallelogram because diagonals bisect each other. All right, 7. ABCD is a rhombus. The measure of angle B is x plus 5. I'm a visual person, so I gotta write that down. Measure of C is 2x. Which statement explains why the equation 2x plus x plus 5 is equal to 180? Okay, so they took 2x from here, and they took x plus 5 here, and they set it equal to 180. Okay, so let's look at the options. Opposite sides in a rhombus are parallel. Okay, that's true. That's totally true. This side is parallel to this side. Totally true. What else? A square is a type of rhombus. Okay, a square is a type of rhombus, but that has nothing to do with why we can set up this equation, so cross it off. Opposite angles in a rhombus are congruent. Yeah, that's totally true. I mean, this angle here, it was congruent to this angle. That's true. And opposite, so this angle here is congruent to this angle. I mean, that's true. So I'll put a little check mark, but I don't know that that has anything to do with our equation. All sides in a rhombus are congruent. Okay, all sides in a rhombus are congruent, but that has nothing to do with how we can set up these angles. So between these two, why can we do that? Well, if you note, if these are parallel lines, and this is your transversal, we are on the interior of those lines, and what I know is we're on the same side of the transversal, so these two angles are same side interior angles. And what I know about those from back in the day is that they add a 180. And that's what they did. So the best answer of choice here is A. Number 8. Diagram below. Late is an isosceles trapezoid. Cool. Isosceles meaning we have two legs of the same length. They say LE is congruent to AT. Alright, so LE and AT are congruent, which means if this is 17, this is 17. LA is 22, it's labeled. ET, E to T, the whole thing is 52, labeled. And AT is, sorry, AT right here is 17. Great, they told me that. Okay, good. The altitudes, so that's just height, is LF and AG. Alright, what's the length of LF? So we're trying to find LF. Okay, so let's do a few things. So we knew this was 17. If from L to A is 22, that would mean from F to G it's also 22. Okay, so if I know the whole size 52, let's subtract 22. 52 minus 22 is 30. So if I take 30 and I split it into 2, now I got these distances, these pieces right here. So 30 divided by 2 is 15. So 15 goes here and here. Again, I want, sorry, my computer's being silly. I want LF is my goal. I have a triangle here. It's a right triangle. This is 90 over on this side. It'd be 90 here. It's a right triangle, okay? And you're given two sides. You got to use Pythagorean theorem, and you're good to go. So Pythagorean theorem: a squared plus b squared equals c squared. Okay, so c is always the hypotenuse, which would be the 17. All right, my x could be my a or my b, so I'm going to do x squared plus 15 squared, and we solve for x. All right, so x squared plus 225 is equal to 289. I'm going to subtract 225 over. And that gives me 64. Take the square root. And x is equal to 8. Alright, so back in there, that is what they want. They want the altitude. They want LF. That's 8. Alright, number 9. Complete the following proof. Alright, they say WXYZ is a parallelogram. We'll draw a parallelogram and label it. Alright, it doesn't matter where you start W. It just matters that you go around X, Y, Z. You can either clockwise or counterclockwise. It's a parallelogram, so we know opposite sides are parallel and congruent. Okay, I want you to prove that triangle XYZ is congruent to Z WX. All right, so that's our goal. They start off with a statement, WXYZ is a parallelogram. Hey, that is given. Great. Cool. Here's your given. Next, WZ is parallel to XY, and WX is parallel to YZ. All right, that's just definition of a parallelogram. Next, they say the angle WZX. Remember, we're looking at the center letter there. WZX. Okay, so we're talking about the angle right in here. Is congruent to YXZ. YXZ. So now we're talking about this angle. Okay, why are those two congruent? And then there should be a comma here. And they're going to list two other angles as well, shown in a different color here. WXZ. Okay, WXZ is talking about this angle. Congruent to YZX. YZX, this angle. Okay, so why would those be congruent? Note you have parallel lines here. This is a transversal. We're on the inside of our railroad tracks or our parallel lines, and we alternate. All right, the colors alternate. So those are alternate interior angles. So I want something about that. Look, if I look here, it says if alternate interior angles of a quadrilateral are congruent. Now we weren't given that first. We are given the fact that we have a parallelogram, so I'm going to skip that one. If corresponding angles, no, we don't have corresponding angles, I'm going to skip that. If two parallel lines are cut by a transversal, now we got something. We had parallel lines, alternate interior angles are congruent. There we go. If two parallel lines are cut by a transversal, corresponding, no, we don't have corresponding, they're just messing with you. And all this other stuff is not what we're looking for. Our next, okay, so ZX is congruent to ZX. Okay, let's find that. ZX is congruent to itself. It's congruent to itself. Okay, that's that reflexive property of congruence right there. And now we can look at the triangles. What do we have? So I'm going to go back here and label with S's and A's. So remember, green, this is an angle, congruent to this angle. This side is congruent to itself. And angle is congruent to angle. So if you place a line tag, start out here, hit an angle, a side, an angle. ASA is why my two triangles are congruent. Boom, number 5. All right, and last question. Parallelogram JKLM, the measure of KLO, so we're talking about that middle letter L, 65. Measure of MLO right here is 27. Find the measure of angle KJM. So we're talking about this big angle here. Well, parallelogram, opposite angles are congruent. So this angle is in pink, it'll be the whole one over here. All you got to do is add 27 to 65. All right, that's 92. So this down here is in total 92. Guess what's up here? 92 degrees. And we're done. Good luck on our test, y'all.